what we're going to do now is we're going to use this relation, the frog jumping, to understand some more mathy terms that are going to be important for the rest of this chapter. Okay? One of them is going to be a linear relation. Okay? A linear relation is basically a graph that looks like what? A straight line, right? Those of you who've taken grade 8 and 9 from me should know that by now. Okay, so a linear relation is a graph, it's a relation whose graph is a straight line. That's what goes in that blank there. Straight line. That's very important. It's also the easiest way to identify a linear relation. You just graph it, and if it's a straight line, sweet, you've got a linear relation. If it's not straight, if it's anything else, it's not linear. Okay? It has to be only a straight line to be considered linear. There are actually other ways to express a linear relation. Okay? It's not just specified to graphing it. You can tell by looking at a table of values, and you can also tell by looking at an equation. Okay? So, we're going to look at these two tables of values. One way that you know a relation is linear is if each column goes up by the same amount each time. Okay, so for example, when I go from this column to this column, this row to this row, how much do I go up by? Going from 8 to 11? 3. Right, I go up by 3, and then this one? Up by 3 again, and then the next one? Up by 3 again, and lastly, up by 3. Okay, let's check the left column. What's happening there? It's going up by 1 this time. Up by 1, up by 1, up by 1 again, up by 1. So because every row in this column goes up by the same amount every time, and every row in this column goes up by the same amount every time, we could say that this is a linear relation. They both don't have to go up by 3, and they both don't have to go up by 1, just as long as every row in that column goes up by the same amount every time. Okay? Let's look at the other table and try to determine whether or not it's linear. Starting with the left column, does that go up by the same amount every time?
Yeah.
Yeah, I'm adding how much every time? 1, right? I'm adding 1 every time. What about the right column?
Nope.
How much do I go up by in the first row? A little mental math there. 19. Okay, what about the next row? 27 to 64. How much? 37. The next one?
65.
61. Okay, and so on. We can already tell, though, that we don't have a linear relation because they don't go up by the same amount every time. Okay, so this is a non-linear relation. Okay, you can kind of, can you guess the pattern? How are they going from the left side to the right side? Do you see it? What do I do to 2 to get to 8? What do I do to 3 to get to 27? 4 to 64?
Oh.
They're cubing it every time.
Oh.
2 to the power of 3 is 8. 3 to the power of 3 is 27. 4 to the power of 3 is 64. Yeah. So question now. The table that you created in 1b, this table, is it linear or non-linear?
Linear.
Linear, why? Yeah, on the right side, we're going up by 2 every time. And the left side, how much are we going up by every time? 1. Going up by 1, up by 1, up by 1, and so on. Okay? That shows that it's a linear relation. Okay? So the answer to that would be yes, because each column goes up by the same amount every time. Or each row in each column goes up by the same amount every time. Turn the page. So what 2 ways can you determine whether or not a relation is linear? First way? Straight line. Second way?
They go up by the same amount.
Table goes up by the same amount. The third way would be in an equation. Okay? This is a little trickier. Okay? You know whether or not an equation represents a linear relation if the degree of every term is 1. Do you guys remember what degree is from grade 9?
Uh,
Let's just do a quick review of that. Quick review of degree. Okay? The degree of 3x squared is 2
oh,
because you add all the exponents of the variables. The degree of 4x cubed y squared is 5. The degree of, let's go 3ab cubed is
3.
4, right?
okay.
3 plus, there's a 1 here.
Oh.
Okay, a to the 1 is still just a. So the degree of 4. What about f? What's the degree of f?
1.
1. What about 6?
1,
0.
0.
Ew.
Why?
Because
It's
there's no
not a
variable.
variable. A variable is
Where's my variable?
it's one.
You're not multiplying. There's no variable.
Technically, there could be.
6 to
If I took any variable, I could just take pick a letter, I don't know, G, and raised it to the power of 0, what happens?
Becomes one.
It becomes 1, and 1 times 6 isn't anything different. Still 6, right? But it does show that the degree, the sum of the exponents, is 0. Okay? So I know whether or not an equation is linear if, maybe I should clarify, the maximum degree of any term is 1. Because sometimes you could have numbers by themselves. So for example, if I had 3x plus 8 equals y. Okay, I've got a degree of 1 here, a degree of 0 here, and a degree of 1 here. That is a linear relation. It will be a straight line. And by the end of chapter 7, you should be able to picture what that looks like in your head. What? I said that too the first time my math teacher told me that. But you will be. You'll know what that looks like in your head at the end of chapter 7. Another example of a linear relation could be something like negative 4a minus 6b equals 10. Okay? I've got a degree of, what is this one? 1, degree of 1, and degree of 0. So the maximum degree is 1. Therefore, it's linear. Last example here. Let's go, I keep using 3. Let's go 9x equals 4y. Do something simple. This is also linear. It's of degree 1. Nonlinear, nonlinear equations. Some examples could be, y equals 3x squared plus 5x minus 10. That should look familiar. What is that?
That's
That's a trinomial. Okay? Actually, it's called a quadratic, which you learn about in grade 10.
Quadratic.
Okay? When you graph it, it looks like this.
Whoa.
Okay? But how do you know from the equation that it's not linear?
Because there's more than one.
the maximum is not one.
The maximum is not 1. The maximum in this case is 2. Okay? Another equation. Let's do this one. Let's go x squared plus y squared equals 36. Is this linear or non-linear? Non-linear. Okay? The graph of this one is, maybe you recognize this shape. It's a circle. Okay, with radius 6. What? How do you know all this? I don't understand. And here's one I recently learned about in my cryptography course. Y squared equals x cubed plus ax plus b.
This doesn't make sense.
What is going on? This is a very cool kind of curve. It's called an elliptical curve. And the mathematics unique to this type of curve are the type of mathematics that are used when you go to like a secure web page on the internet or email or your bank account or something like that. The mathematics that govern this equation and this curve are used to build security measures in software. The equation in 1D, this equation that we made for Jorge, where is it? Here it is. Is that linear or nonlinear? Linear, definitely. Right? The maximum degree of all the terms is 1. Good.